What if the world around you is not as solid as it seems? For centuries, we believed reality was made of physical matter, solid, measurable, predictable. According to classical physics, the universe followed clear and deterministic rules. Objects had defined positions, light traveled in straight lines, cause always produced effect. Reality appeared stable and objective. But in the early 20th century, a simple experiment forced scientists to question everything. It suggested that reality may behave differently when we are watching. In 1801, physicist Thomas Young conducted an experiment with light. He projected a beam of light through two narrow slits onto a screen. If light were made of tiny particles, we would expect to see two bright lines on the surface behind the slits. Instead, the result was unexpected. An interference pattern appeared, a pattern that only waves can produce. Light, it seemed, behaved like a wave. Decades later, scientists repeated the same experiment using individual particles such as electrons. They fired electrons one at a time toward the double slit. The result was even more disturbing. Even when sent individually, the electrons gradually formed the same interference pattern. It was as if each electron was behaving like a wave, passing through both slits simultaneously. How could a single particle exist in multiple paths at once? Then came the most astonishing discovery. When scientists placed detectors near the slits to observe which path the electron actually took, the interference pattern disappeared. The electrons behaved like ordinary particles again. Two clear lines appeared on the screen. The mere act of observation changed the outcome. Reality seemed to respond to measurement. This phenomenon became known as the observer effect. In quantum mechanics, particles do not have definite properties until they are measured. Before observation, they exist in a state of probability, a range of possible outcomes. Only when measured does that probability collapse into a single result. Modern physics accepts this behavior. Quantum mechanics is one of the most accurate scientific theories ever developed. It powers technologies such as semiconductors, lasers, and modern computing. Yet its implications remain unsettling. If reality at its most fundamental level is not fixed, if particles behave differently when observed, then what does that say about certainty, about determinism, about the nature of existence itself? The double-slit experiment did not destroy science, it transformed it. It revealed that beneath the solid world we experience, there is a deeper layer, one governed not by certainty but by probability. A layer where observation matters, a layer where reality may not be fully independent of measurement, and perhaps a layer that reminds us that the universe is far more mysterious than we once believed. Welcome to Enigma.